Did the video start? Well, hey there, Mustangs. How you doing? I have no idea what's going on. Welcome back to another edition of No Here, No Problem. Rosenwald here, working on section 4.7 inverse trig function notes. Today, we're going to be representing the Kansas City Chiefs. I have no interest in supporting them, but my son really liked them and he had this hat, and I stole it from him for this video. So, anyways, today we're going to be doing something that has a little backstory for it first before we actually get started. And then the problems that we do, the explanation for these problems is actually significantly longer than the actual problem itself. But I need you guys to understand kind of what's happening as we do these. You are going to watch your unit circles I have nearby, and I will keep one, as you can see down here, as we work through these, so we can kind of reference them, okay? Let's go ahead and get started. Move me out of the way here as always, and let's dive in. So the first thing I'm going to do before we start on this is I have to take you guys through why we do what we do in this. You'll see something boxed out right here on the screen. I'm going to go down to the bottom of my screen here so we can actually reference things a little bit here to make better sense of everything, okay? When we look at a sine curve, and this will be the same for cosine and for tangent, by the time I'm done explaining this, hopefully you'll just take cosine and tangent as face value. But let's talk about the domain and range of this function here, okay? So this is the way a sine curve actually looks. And when we look at each one of the coordinates that are embedded in here, you'll see that we have a point right here that's at 0, 0. We have pi over 2, 1. We have pi, 0, 3 pi over 2, negative 1, and then 2 pi, 0. Now, these five values are actually coming from our unit circle here. Actually, I should say our unit circle is derived from those 5 points. And so when we see here, as we go around, we have 1, 0. And I'm sorry, we have 0, 0 right here. And then we have 0, Jesus. We have pi over 2, 1. And then we have our next point here is pi, negative 1. I'm sorry, pi, 0. And then we have 3 pi over 2. And then we go back to this. And these are the 4 spots that we go through in like a cyclical behavior. When we look at the domain and the range for this, you can see that as I go to the right, this will technically go forever. And then as I go to the left, this will technically go forever. So the domain for this function is negative infinity to infinity. As I look at the up direction, it caps itself at positive 1. And then as I go in the down direction, it actually caps itself at negative 1. So the range for this is just positive 1 and negative 1. Now, if I was to take the inverse of this and I switched all of the coordinates for this, so the 0, 0 would switch, the 1 pi over 2 would switch, the 0 pi and so on and so forth would all switch. This is what my new picture would look like. Now, if you recall as we're doing functions, you should remember there's a rule that we use to determine if something is in fact a function. So when I look at this right here, the rule is actually the vertical line test. And what that says is that as long as I can draw only one point through the vertical line of this, we would have this technically a function. Well, what ends up happening is when we go ahead and look at the inverse rule is that the horizontal line has to pass only one point. And as I look right here, it does pass one point, but you can see right here when I draw a horizontal line, it ends up hitting 2 separate points, right there and right there. And that's verified by the fact that when we go ahead and draw this, and we draw the vertical line, when we do the inverse of this, what ends up happening is we can see right here that when I draw a line through it, my inverse is not a function. Well, we run into a problem because of this. The fact is that when we're trying to find and work with the inverse functions, I need it to be a function. And so when we looked at the domain and range of the original function, it was negative infinity to positive infinity, and range was positive 1 and negative 1. And when we switch these, this is what happens is my domain and range switch places, right? Well, I can't work with this because what ends up happening is I can't find a value. I have the same values over and over and over. So what do? Well, what we do is we actually take and we cap this off at a certain point. We actually cap it right within this region right here. The reason we do that is that this area right here in my picture has every single value of sine embedded within it, okay? And so I could draw a horizontal line through every single spot, and it's going to work. The inverse would be a function. And as I draw a vertical line through everything, we still have a function. So our inverse and our original function is still a function in both cases, right? So I don't need all the extra stuff because a point right here is the same as a point over here, right? And a point down here is the same as a point over here. So I don't need all the redundancies. I really just need a little region to work with. And so we go ahead and we use from negative pi over 2 to positive pi over 2. And that means that the range hasn't changed, though. If you look at the top of this, it's negative 1 and positive 1. And so those are the range, negative 1 to positive 1. So if I say, well, let's go ahead and use these instead and get rid of this, then my domain and range over on the inverse also switches, and we get from negative 1 to positive 1 is the domain, and that the range is from negative pi over 2 to positive pi over 2. And so that says that we're going to actually take and cap it right here, okay? And we have this portion of my graph that we're actually looking at. Now, why is this important? What does this mean for us? Well, it goes up to the top here, where it means that we are going to go ahead and focus solely on the domain and range being from negative pi over 2 and positive pi over 2, and then negative 1 to positive 1. So when we look at the unit circle, long explanation to get there, but here's what it is, okay? That in order to get the inverse of a sine function, our answers have to be from negative pi over 2 to positive pi over 2. Well, here's where positive pi over 2 is. Here's where technically negative pi over 2 is, because remember we go this direction the same length, so it's negative pi over 2. That means that all of my answers for this have to sit somewhere in this area right here. So what we're going to say is all of our answers that we're getting for the inverse sine are going to sit in the first or the fourth quadrant when we're using the unit circle. Okay, so in the first or the fourth quadrant is where our answers are going to exist. Okay, so a couple of things. Inverse sine. Inverse sine is not the same. Okay, inverse sine is written as sine of negative 1, like this, or arc sine. This is the two different ways that you can actually see inverse sine written. And a common misconception is everybody thinks that when you see a negative there, it means that same thing as 1 over sine, which is not the case, because that's actually what we know is cosecant, okay? So that's the first misconception we have to clear up. The second thing is that when we're talking about all of the inverses, we said that all of your answers are going to exist from negative pi over 2 to positive pi over 2, which means decimal-wise, we're looking at negative 1.57 to positive 1.57. And if we're looking at angles, we're talking about all of our angle answers should be from negative 90 to positive 90, okay? So that just means that if we have anything outside of those answers, we'll have to talk about coterminal angles, okay? So let's get started on some problems here. And as I said, the explanation is longer than the actual problem itself, and you are going to want to have your unit circle readily available so we can actually work with it, okay? So let me go ahead and drag mine down here so we can actually work with it in a moment. All right, we'll see how quickly these problems work out with it. Here's the first thing we're looking at. And this is, I need you to understand the lingo that's actually taking place here, okay? So when it says inverse sine of 1/2, when we look right here, this says inverse sine of 1/2. Here's what this is actually saying. This says the inverse sine of 1/2 is equal to what? Right? That's what it's asking. It's like, what is it actually equal to? Right? Well, the correct way to write this then is the mindset is, well, what angle has a relationship where the opposite of this angle is 1 and the hypotenuse is equal to 2? So the way we would write this in normal text would be the sine of what angle is equal to 1 over 2. The sine of what angle is equal to 1 over 2. Well, let's think back to what we know, okay? The sine of what angle is equal to 1 over 2? Well, here's what we remember. We know that sine right here is the same as y is equal to 1 over, oh, I'm sorry, I don't want to get there yet. So sine of theta is equal to 1 over 2. So let's go ahead and draw my triangle here. We've got our angle right here. And what I've got is my opposite, well, show the answer on accident. My opposite over my hypotenuse is equal to 1 over 2. So my opposite is 1, my hypotenuse is 2. And when we look at this relationship, we know that all of them are positive over here. Well, I could technically draw it over here as well, right? We get a 1 and we get a 2, okay? The problem is that when we look at the fact that all of my inverse sine answers has to exist over on this side, you can see that right here, this one does not exist in the correct location. And that means that this one gets taken off of the table. We can't use that one as part of our answer. So that means that the only place where my answer can exist is going to be in this first quadrant. We can ignore this. So then we say, well, what is it? When we look at the angles, 1, 2, and we know it should hopefully know that this is root 3. The smaller angle opposite of theta here is always going to, I'm sorry, the smaller side opposite theta is when theta is equal to 30 degrees. Okay? And so we can say that theta is 30 degrees in this case. Long answer, but believe me, there's actually an easier way to do this. You ready? We know that the sine of theta is actually equal to y. So y is equal to 1/2. And what we're going to do is we're going to use our unit circle. Take a look at this. When we use our unit circle here, we are going to look at this and go, okay, where is, whoops, I said the wrong thing there. Where is, jeez, I don't know what's happened. All right, whatever. I'm going to delete this thing because I don't need this. And I'm going to look at this instead. There we go. All right, so then when we look at our unit circle that's going on here, we are asking where do we have a y value equal to 1/2, right? That's all we're asking. Where is the y value equal to 1/2? And when we look at this, you can see that the y value right here is equal to 1/2 and the y value is equal to 1/2 right here. The issue is that my answer has to be over in this quadrant here or in this quadrant here. And because it's a positive 1/2, it's going to be 30 degrees. That's it. Okay. So now if we look at the next one, letter B, it says the sine of what angle is equal to √3/2? And what we're really saying is when is the y value equal to √3/2? Well, let's look at √3/2. The y value right here and the y value right here is √3/2. That exists right here at 60 degrees or pi/3. Okay. For the next one, it says the sine of what angle is equal to negative √3/2? Well, when we look at this, negative √3/2 is right here is one of them, and then right here is the other one, right? Well, when we look at this, it says that the sine is equal to negative. Well, this is all students take calculus, right? And we know that the sine is negative in both of these, which we've got, okay? Well, the inverse sign can only exist in these two quadrants right here, in this quadrant and in this quadrant, right? Well, I don't have a negative y value in this. So what happens is I look right here, I've got a negative y value here, and it's in the fourth quadrant, and the answer for this is equal to 300 degrees. Okay, so that's 300 degrees. Now, this is the restriction of my answers, right? I can't have 300 degrees. If you go back up to right here, my answer, all answers have to be between 90 degrees and negative 90 degrees. So 300 is too big. So this is where we use a coterminal angle. Remember, coterminal angles, we just take away 360 or we take away 2 pi, or we add 360 or we add 2 pi. So in this case, I take away 360, and what this does is it gives me negative 60 degrees. And negative 60 degrees is going to be equal to negative pi/3. Okay. All right. Let's move on here. Okay. So let's continue on here. So when we look at these problems, these are composite problems. The question becomes, what do we do first? Well, whenever you're working on composite problems, you always work from the inside out. Okay. And so in this case, the sine of 3 pi/4, we are asked first, what is the sine at 3 pi/4? So let's look at a unit circle. I don't even do that. I've got the unit circle up here. At 3 pi/4, what we're looking at is 3 pi/4 is right here. The y value is equal to √2/2. You see it? So then if we say, well, what is the sine at 3 pi/4? We know that the sine is going to be √2/2. So now that value gets moved over to here, which is what we had, √2/2. And now I'm asking, well, where is the sine? Sine of what angle is equal to √2/2? So this is part 2 now, is the sine of what angle is equal to √2/2? Well, again, since we're doing inverse sine, my only answers that I can have to exist in the first and the fourth quadrant. And so I'm saying, where do I have a y value equal to √2/2? Well, that's right here. And that happens at pi/4. Okay? And so my answer for this is pi/4 or 45 degrees. Okay? Take a look at letter E. This is one where we don't actually get to utilize the unit circle. Okay? We have to actually mathematically work through this. So in this instance, I say the sine of pi/5. Okay? Well, where is that? Where is the sine of pi/5? The pi/5, if you think about it in terms of degrees, pi/5 is like 180 divided by 5. So we're looking at the sine of like 36 degrees. Okay? This is what that says. The sine of 36 degrees is how you can look at this, if that'll help you. Well, 36 degrees exists up here, somewhere in this region. So let's go ahead and draw a triangle. And so I'm not given any numbers, given nothing. All I'm given is that we have theta and we have opposite over hypotenuse. That's what we know the sine of this is equal to. So at this moment, I know that the sine of 36 is equal to opposite over hypotenuse. That's all I've got. I don't have any numbers. It's not on the unit circle. I've got nothing. So now we say, all right, well, where does the sine of theta equal opposite over hypotenuse? Oh, jeez. Okay. Where does the sine of theta equal opposite over hypotenuse? Well, the opposite over hypotenuse can only exist in two locations for sine. We have all students take calculus. This is a positive value, so it can exist either here or here, right? And since we're doing inverse sine could only exist in the first or the fourth quadrant. So that means my triangle is currently drawn in the correct quadrant. So that means I look at this situation, and I say the sine of what angle is equal to opposite over hypotenuse? Well, the angle that's there is pi over 5, okay? So this is the first time we see the question, can inverses cancel out original functions? These are opposite one another, so they could technically cancel each other, but not always, and you have to be careful. Your answer has to sit in the correct quadrant when we're doing these, okay? Just like positive and negative cancel each other, and multiply and divide cancel each other out. Well, the same is true when we have sine and inverse sine. They can cancel each other, but it has to be in the correct quadrant in order to do so, okay? All right, one more problem here on sine, and then we're going to move on. All right, so sine. Let's look at cosine. Cosine of 3 pi over 4. Go ahead and look at 3 pi over 4. And what we're going to see is right here at 3 pi over 4, we're asked what's the x value there, which is negative root 2 over 2, because that's what cosine is, the x value, right? And so now we know that it's going to equal to negative root 2 over 2. So then we're saying, well, this inverse sine of what angle is equal to negative root 2 over 2? And now we have to go over here and say, well, where do I see a y value equal to negative root 2 over 2? And this is where we have a y value equal to negative root 2 over 2, and same with here. But only one of these is in the fourth quadrant where it belongs, and that's this one right here. Now that 315 degrees, though, is outside of where it can be. And so we can't use 315, so we have to go ahead and use coterminal angle, which means we take away 360, and we're going to put negative 45 or negative pi over 4. Okay? All right, a couple of problems to try in your calculator. Inverse sine of negative 0.73 and inverse sine of 3.45 pi. You throw those in your calculator, you should be able to get those. Just make sure you know how to use it. But these are the answers you're working towards. And now we're going to switch over to cosine and tangent. Now, this is going to work out exactly the same way as far as us having domain restrictions. Excuse me, sorry. So domain restrictions, when we look at this, we can see right here that they've restricted our graph, and the graph for this happens from 0 to pi. That's the restriction that we're going to actually use. So when you look at the unit circle, from 0 to pi means all of the answers for inverse cosine are going to exist in the first and second quadrant. Mathematically, what does that mean? We're going from 0 to 180, or 0 to pi, or 0 to 3.14 for all the inverse cosine. When we look at tangent, you can see the original function right here looks like this, and it's from negative pi over 2 to positive pi over 2. And that means when we look at the reciprocal of this, not the reciprocal, the inverse, I'm having brain farts here, it's going to be from negative pi over 2 to positive pi over 2 as well. So this is exactly like sine. Exactly like sine is that it's from 1 to 4, but there's one slight difference. What happens is these values are not going to equal anymore, okay? These values are going to be around, but they will not equal, okay? They're going to be around, but they will not equal. Why? Well, what happens is when we say tangent of theta is equal to y divided by x, and we look at the point right here at the top, for example, this value right here is equal to 0, 1. And if I do 1 over 0, what ends up happening is we get the tangent of theta is equal to undefined. Can't have undefined for a number, so we say it's undefined. And that's why right here we cannot include those values because they generate undefined values at those locations. Okay? All right, unit circle time. Let's go ahead and let me grab that unit circle and we'll pull it down here so we can work with it. Okay, and so let's get rolling here. So first off, cosine of root 3 over 2. I'm saying, okay, cosine of what angle is equal to root 3 over 2? I'm saying, where do we have an x value equal to root 3 over 2? Look at your unit circle. X value equal to root 3 over 2. And sorry, that's here and here. And the only one that's in the first quadrant where it belongs is this guy. So that means my answer is 30 or pi over 6. Okay. When we look at the inverse cosine of negative root 3 over 2, we're saying the cosine of what angle is equal to negative root 3 over 2. So we're looking for an x value equal to negative root 3 over 2. And that happens here and here. But the only one in the correct quadrant is over here, because that has to be in the first or the second quadrant. So my answer for this is 150 or 5 pi over 6. Okay. When we're looking at inverse tangent, what we're saying is the tangent of theta is equal to 1. So we're saying, where do I have a relationship where the y value divided by the x value, or the opposite over the adjacent, is equal to is equal to 1? And again, tangent has to exist in the first or the fourth quadrant. Well, let's look at our unit circle. The only way I can get a y divided by x to equal 1 is going to be right here or right here. You're looking at the numerators right there, y divided by x. And remember, we always said when tangent, you just ignore the denominators. Well, only one of these will work, because when I look right here, this is going to generate a -1 relationship. And when I look right here, this will generate a +1 relationship when I do the y divided by the x. Okay? And so if that's the case, my answer for this is going to be pi over 4 or root 45 degrees. When we look at the inverse tangent of -1, we're saying, where do we have a relationship where the y value divided by the x value is equal to -1? Okay. And so let's look at that. We just went over that when we look at this, it has to be in the first or the fourth quadrant. And we look at the relationship, it's going to have to be one of these two. And the one that gives us the negative that we're looking for is going to be right here at 315 degrees or 7 pi over 4. But again, remember my answers have to be from -90 degrees to +90 degrees. 315 does not fit inside of that. So we take away 360 and we're talking about -45 degrees or negative pi over 4. Okay. All right, last one, and then this is it for the notes here. When we look at the cosine of -1.5, this is very obscure. This is throwing people off when we see this, but again, this is no different than anything we've seen before. It's kind of close to negative pi over 2, because we know negative pi over 2 is like -1.57, okay? So when we say -1.5, that's less than -1.57, and what that means is that we are looking at a triangle that's going to exist right over here, somewhere in this region. If I was to go to negative pi over 2, that would take me all the way over here, and we're not quite there. So the only thing we're looking at is over in this region right here. That's where cosine of -1.5 is. Okay, so let's draw that. Let's draw that. When we draw that, here's what we end up with. This right now we know is -1.5 radians. Okay, and the relationship here is that we know that this is -1.5 radians, just like because we don't say degree sign, right? So we know it's -1.5 radians. And so what we're saying is, well, what's the relationship at cosine of -1.5? There's no numbers. I don't know. But we do know that this is the adjacent and the hypotenuse here, right? So when we look at this, and I'm sorry, I wrote that negative pi over 2 is -1.57, just so we had a reference, okay? And so what we're saying is, where do I have now, because we did the first part, it's just adjacent over hypotenuse. So what we're saying is, where do I have an angle that's equal to adjacent over hypotenuse? Well, the problem is that cosine has to be positive, right? Cosine is only positive. We have all students take calculus. Cosine is positive here and here, right? And if we're doing inverse cosine, it can only exist here or here. Well, that shows you that when we look at this, we have that overlap right here. So that means when I look at this, my overlap has to actually be in this quadrant over here, where we're going to put it. And we have the adjacent, we have the hypotenuse. And then we think about, all right, well, what's the angle that's here? It's pretty easy. It's 1.5 radians rather than -1.5 radians, because it has to be exactly the same. And so we end up with theta is equal to 1.5 radians. That is it. As I said, I think you guys can totally handle these if you just make sure you have your unit circle nearby. There are going to be problems where you might not be given everything where you have to use Pythagorean theorem, but that should be second nature for you guys at this point. Give them a try. You've got this. I believe in you, as always. You guys take care. Be safe. Be respectful. Be responsible. And don't forget to like and subscribe to my channel. Have a good one.